Hi, I'm Dr. Francesca Hopkins of the University of California, Riverside, and I'd like to talk about Vista, California, which is a facility scale inventory of dairy methane emissions. Why do we need to do an inventory at the facility scale? The California Air Resources Board already has a greenhouse gas emissions inventory, but they only produce one number for the whole state. We know that California's diverse dairying regions have different management practices and different climates, and it's very important for us to include that in our inventory to understand how to best distribute different types of methane mitigation and to independently verify the effectiveness of mitigation techniques that have been implemented. So essentially what we wanted to do is come up with a farm scale baseline for methane emissions across the state. We published this last year in a paper in Earth System Science Data. It's freely available at this link here. So what we did is we identified the locations of dairy farms across California by inspecting satellite data, and we found over 1,000 individual farms. We got herd numbers from permit data and compared those with county level animal inventories. And we calculated enteric methane emissions using CARB methodology, most recently published by Apumi and Kabrab in 2018. And we estimated manure methane emissions using information about regional management practices and what we found in those water quality permits. So for the state's dairying regions, the San Joaquin Valley, the North Coast, and Southern California, here in this table, I'm showing the percent of manure that's handled by each of these different management systems, each of which has its own different methane emission signature. So what did we see? This map here on the left is showing our inventory, which did not differ in the total from CARB's inventory. It just spatially distributed those emissions. And you can see two big hotspots in the San Joaquin Valley, and then our other dairying regions of the state in the North Coast, the Northern Sacramento Valley, and in Southern California. We also calculated the ratio of enteric to manure methane, and you can see that the enteric fermentation provides a larger percentage of farm methane in a place like the North Coast. So you might want to target your mitigation strategies if you're in this region towards enteric methane. And then we looked at the differences between the EPA's inventory, which is spatialized with our inventory. And what we found is that the hotspots of methane appear much larger in our inventory compared to the EPA, which overestimated emissions in all these red regions. And then in this gray region where EPA thought there should be dairies, we actually don't think there should be any dairy methane emissions. Finally, we did an analysis of how digesters that were funded in 2017 through 2019 will decrease emissions. And we found that in the locations where digesters were planned, shown by the black dots, there is a reduction equivalent to 36.5 gigagrams of methane per year, or 5% of the state's dairy methane total. So in conclusion, we found that emissions are not different from what CARB saw, but we saw that if we looked at the spatial patterns, the hotspots are even more intense, and we can really investigate the differences in regional climate and management on overall emissions and what processes they come from.